All right, welcome to week 3 science. We're still in our electricity unit, but we're moving on to how electricity is produced. And so we're going to start that off by exploring fossil fuels. So we're going to learn about the origin of fossil fuels, and then we're going to look at the energy transformations that occur in order for us to end up with electricity. And of course, most of our electricity at the moment is generated from fossil fuels. And so, what you'll be doing is developing your understanding and your ability to draw the actual energy chains that occur in order to produce electricity. So, the first question there is, have you heard the term fossil fuels before? And no doubt you have. I'd like you to jot down what you think it means. Pause the video and write down a little statement about what you believe fossil fuels are. All right, I'm actually not going to go over what a fossil fuel is at the moment. We'll come back to that at the end and see if you can make a change to what you said. All right, let's move on. This is a video about coal.
Coal is called a fossil fuel because its energy was captured around 260 million years ago during a geological period called the Permian. During the Permian, our coal mines of today were broad, flat areas of swamps located on the banks of ancient rivers. The plants that grew in these swamps dropped a large amount of leaves, branches, and seeds into the swamp waters as part of the natural cycle of growth and decay. Over many thousands of years, the swamp environment transformed this decaying plant material into a spongy substance called peat. If this peat remained uncovered, it finished decaying and oxidized. However, if large amounts of rain fell, mud, rocks, and silt will wash down over the peat, burying and compacting it deep underground. Or, erupting volcanoes would bury the peat under layers of ash. Whenever the peat became buried, the plant life on the surface would re-establish and begin the process over again. Over time, the Earth's geothermal heat worked on the compacted peat to drive off water and other volatiles like hydrogen, nitrogen, and oxygen. This heat gradually matured the peat into hard chunks of carbon material that we now know today as coal.
All right, so that was a bit of a video about how coal was formed. There are others on the internet. That one was a fairly short one, and that's why we included it, but the visuals weren't all the best there, were they? So if you want to have a bit more of a detailed look, you can search and find some other videos which go into a bit more detail than that one did. All right, but that gives you an idea about where our fossil fuels originated. So let's see how well you listen. There's 3 little true or false questions here, and you've got to jot down whether you believe the statement is true or false based on what we just watched in the video. The first one, the coal we use today first started to form 260 million years ago. Is that true or is that false? And that is true. Coal is not a fossil fuel. True or false? Pretty easy one, that one. It's definitely false. Of course, coal is a fossil fuel. Then the third, true or false? Buried peat eventually turned into coal. Is that true or is that false? And the answer is true. All right, fossil fuels are formed over a long time from the remains of plants and/or animals. Some types of fossil fuels are coal, natural gas, and oil, also called petroleum, shortened for us to petrol, although that is a refined version. Presently, fossil fuels are used as the #1 energy source across the world, and approximately 80% of the worldwide energy use is based on fossil fuels. Now, obviously, if 80% is based on fossil fuels, and it takes millions of years to form, you should see a bit of a problem there. And you're indeed right, we are rapidly running out of our reserves of fossil fuels. Okay, so now we're going to go on and have a little look at how those fossil fuels are used. The main 3 are natural gas, coal and oil. And we can actually use it in our households in bottles. So if you've got a gas barbecue, that's the gas that's used in there. It can be used for heating and cooking, but natural gas is also used in power plants for generating electricity. However, more within the power plants, coal is used. Most of our electricity comes from coal burning and so forth. But a large number or a large amount of coal is also used in the production of steel. Oil is used to produce plastics, believe it or not. But oil is an amazing thing. There are a whole lot of things that come from oil originally, but they come out at various stages of the processing of oil. And even a range of fuels come from that. So at the petrol station, you can get the normal petrol, you can get diesel, we can get LPG, and not at the petrol station so much, but kerosene is another offshoot of oil. Now we're looking at the energy chains. So there is a learning object that you can open and explore yourself, but we'll be looking at that learning object over the next few lessons. We're going to particularly focus today on coal and tomorrow on petrol. But electricity is generated on a large scale in a power station. For fossil fuels to generate electricity, they must undergo a number of energy transformations. So basically, fossil fuels are stored energy, and so when they're burnt, they generate heat energy. So stored energy to heat energy. The heat energy heats up a boiler of liquid, usually water, and that produces steam. The steam then spins a turbine. A turbine is a propeller type device that produces rotational. So we had stored energy, heat energy, rotational energy. So you can see it's a transformation of the energy from one type to another. That rotational energy of the spinning turbine connects to a generator, and the generator is able to actually transform rotational energy into electricity. Let's have a look at the learning object. All right, so this is a bit of a repeat of the information. I won't go through that again. You can read it at your own leisure, so if you want to read through that, you can pause it. But this is what the learning object looks like. So let's explore what coal looks like in the energy chain. And it did it again to me. All right, that shouldn't have happened. This is better. So it's going through a diagram, a flow diagram or a flow chart that talks about the different parts. The first part being coal. Coal is dug up from the ground and stored in massive supplies before it's taken to the power stations. The next part of that is to burn the coal in furnaces. So actual trains, the old-fashioned steam trains used to burn them, but power stations have huge furnaces. And that heat generated through burning it is used to boil water to the point where it turns into steam. And if you've ever seen the power stations, these massive chimneys allow the steam to escape after it's finished its process. The steam turns the turbine. So that's your example of rotational energy. If you want to know how big they are, those are people there. Aren't they big? Huge things in power stations. And the next thing is the generator. Generators aren't small either. You mightn't see it too well, but these here are railings. So if that's a railing, comes up to about half the height of an adult, you can see how big these are. All right, so that's an energy chain for the way that coal is turned into steam. Oh, sorry, into electricity, silly me. All right, let's have a look at how that looks. So you've got to complete this task here yourself, but this is an example of it. And this comes into your assessments as well. So this is the energy chain for coal. And in the learning object, you start with whatever you're having. In this case, it's coal as an energy source. Take it to the furnace. So the furnace is the next step down here. To the boiler, which is the next step here, producing steam. Do you remember what steam turns? If you said turbine, you're correct. Turbine is this part here. And that takes us through the turbine. What is that connected to? The turbine connects to the generator. There's your generator. And once everything's connected, the light came on. All right. So the second part of the learning object then has us review what we've learned. And these descriptions are dragged down into the box. So it says you have selected coal as your energy source. The coal is burned to release heat. Now, of course, we know that the heat boils the water, which turns it into steam. The steam then pushes a turbine, making it rotate. And the turbine then, in turn, spins the generator, converting the rotational energy into electricity. All right, so your task now is to complete this part here yourselves. So pause the video and see if you can transfer this information into this section. Pause the video and then we'll come back and check to see how you went. All right, how did you go? So what do we do with the coal? Again, I'll remind you, this is part of your assessments or learning for the assessments to be able to recognise and write down the energy chains involved. We don't get a piece of coal and plug our computer into it. We don't plug a fan into the coal and instantly have electricity. It has to go through a chain or a process before coal is usable electricity. So the first thing you should have included was the furnace. Now you could have either written the word or drawn a picture. The furnace heats or burns the coal to boil the water. So it's connected to the boiler. The boiler, the steam that's generated, spins the turbine. Notice the pipe here narrows. And that's the way we get a lot of pressure in pipes. Our water pipes work the same way. We go from a wider pipe to a narrower pipe. And with the volume of water trying through, and in this case the volume of steam, it builds up pressure and speed, which will spin the turbine faster. Or with a hose, it'll make the water come out in a jet form. The turbine connects to the generator, and if we have a correct energy chain, the generator will produce for us electricity and the lights go on. All right, that's it for today, guys. We explored fossil fuels and how coal becomes electricity for us. We'll explore other fossil fuels in the next lesson. And then in subsequent lessons, we're going to actually have you do some research as well and explore some of the alternatives to fossil fuels, our renewable energy sources, as we call them. Because as we said before, these won't last forever. Which reminds me, how did you go with your initial description of what a fossil fuel is? Did you come up with a good one, or do you now want to change it a little bit now that we've been through this process with coal? All right, thanks guys, done for today. Catch you for science tomorrow. Bye now.